Hello, stalagmites and stalactites. Well, before we get started, I have a little story for you. I messed up an interview with a phone interview with a certain social network company before even the interview started. I think I messed up that sentence. Well, here it is. The time that we set the phone interview for was 2:30 Pacific time. I live in the East, and in my mind, because I'm used to dealing with Europe, somehow I associated that time, the 2:30, with 11:30 Eastern rather than the atrocious 5:30 Eastern. This is a mistake. You want to be at your most active. You want to be in your best conditions, in your most awake conditions, in order to solve the problems. Because you could solve the initial, you could say the linear problem. You could solve everything in linear fashion if you kind of studied and you know your coding, but to reach the optimal solution and to keep plugging away at a problem, you need to be awake once again. So that was my mistake. I was kind of rambling on about how I would optimize my solution, and but somehow I couldn't formulate the proper structure. In this sense, it wasn't completely clear to me, and I was too tired to kind of come up with two or three solutions on the fly, which normally I would be able to. So that's the recommendation. Don't set a time when you'll be tired. I recommend 11 o'clock in the morning as being the best time for a phone screen, because you just ate. Even if you didn't get a good night's sleep, you could do a power nap before 11 o'clock, and you'll be fine. So let's get on with keys and rooms, because I've already spoken for 2 minutes about this. There are n rooms that you start off at room 0. Each room has a distinct number, 0, 1, 2, n minus 1, and each room may have some keys to access the next room. Formally, I don't know why they use that word to introduce the sentence, each room I has a list of keys, rooms I, and each key, rooms ij, is an integer 0, 1 to n minus 1, where n equals room's length. Okay. A key rooms ij equals v and opens the room with the number v. So all this is saying is that if you have an input here, and this would be 0, you know that from room 0, you could pick up the key to 1. From key 1, you could pick up key 2. From room 1, you could pick up key 2. From room 2, you could pick up key 3. And then you go to key 3, and you're golden. Essentially, you're fine. That's exactly what you could do. Now, from here, from key 0, you could go to rooms 1 and 3. But you can't go to room 2. So you could go, and then from 1. Oh, okay, but wait a minute. Let's see now. We can't enter the room. We can't enter the room with number 2. So there is a room 0. We could go to room 1. That's fine. And then from there we go to, and then from room 1. So you could either go to 3. Yeah, we'd have to, yeah, we can't enter the room with number 2. Yeah, in this sense. So how do we follow that? From room 0, you could go to rooms 1 and 3. From room 1, you could go to itself and 1, 3. Yeah, you can't actually hit this one over here, which would be room number 2, actually. This is room number 2, and it kind of points to itself. So you can't actually go there. And that's a problem. So there you go. So let's see how we could do this. Well, we want to know if we could visit all rooms. So first of all, let's come up with a set of visited rooms. Now, let's see now. Our condition is if eventually we visited all the rooms, it would have to equal rooms dot size over here. Okay. That's our first condition. Now we'll solve this using a depth first search. So, okay, we already came up with visited over here. what we want to do to solve this is come up with a stack, which is a good model to have to solve a depth first search problem. And what we want to do is insert the starting room in there, and we'll at each, and we'll stack it up onto the stack. We'll push it onto the stack, and we'll iterate through the stack, meaning we'll pop every item in the stack, and we'll look at its associated keys, meaning its associated rooms. And if we haven't seen those rooms before, we're going to stack them, and if not, we're just going to ignore them. So it's going to pass through all the rooms. If at the end it can get to any of the rooms, then we're fine. And if it doesn't, we'll return false, which is what we said over here. So let's see now. So the first thing is, actually, we'll call this rooms over here. So let's set in, actually, sorry, no. I'm still going to call this my stack, because we'll make this a generic type of thing. Let's see now. So first we want to immediately put in our first node over here, our first room, and for const auto element rooms 0. Okay, so now we want to check what are the associated rooms here. So let's see now. My stack dot push element. Okay, so now we've already visited room 0. That's what we have. Now we're going to visit all its associated rooms, and yeah, exactly. We're going to visit all its associated rooms, while my stack not empty. Let's see now. So int current room equals my stack dot top. This is the room that we're looking at so far. My stack dot pop. Now the thing is, these two operations are two different things in C++. In Java, they're the same, but and I think it has to do with it being thread safe or not. So now, okay, so if visited dot find, let's see now, current room equals visited dot end, that means we haven't seen it. If we haven't seen the room, if we haven't visited the room, then the first thing we do is we inserted. Then now we do visit the room. So let's see now, visited.insert current room, and we once again get all the elements associated to that current room, which is, how do we do this? Rooms, current room, right, okay. And we do the same thing that we did here, you know, let's just use that same structure over here. We do that again, and is this it? Let's see. What's its problem here? Warning, if statement, oh, sorry, this should be return. Okay, it looks like it worked here. And it looks like we have a winner. Thanks a lot, everyone. And remember that piece of advice. Good night's sleep and good time for the interview.